first task is about production externalities. From the lecture, you know that, what is the externality. Is the situation when you decide by your own what to do, and in this situation you think only about yourself. But your decisions can influence other people positively or negatively, but you don't care about it. That's why here is the problem of externality. For example, if you smoke, you decide how much to smoke by yourself, but it hurts other people. It's bad for health for other people, but you don't care. That's why here is the problem of negative externality, and here is the problem of over smoking. You smoke too much if we compare it with the socially desirable level of smoking. The other example of positive externality is vaccination. Here is the problem of under-vaccination. Why? Because when you decide to vaccinate yourself or not, you care only about yourself, and you do not take into account that when you vaccinate yourself, it positively influences other people. Yes, because the probability of getting infected of other people decreases also. Yes, and we think only about ourselves. That's why we rarely go and do vaccines and make vaccines. Okay, so today we'll speak about in this task about production externalities. It's a classical example. Let's read. Consider two perfectly competitive firms, steel mill and fishery. Steel mill and fishery. They are perfectly competitive firms. Let PS, respectively PF, denote the price of steel, respectively fish. The price of steel equals to 10. The price of fish equals to 5. On perfectly competitive market. The steel mill has the following cost structure. Total costs of steel, depending on the production of steel and the use of water. X is the use of water, equals to S squared divided by 2 plus 4 minus X squared. The costs of fish production, depending on fish production, and the usage of water by steel mill, equals to F squared divided by 2 plus XF. So what we can see, we can see that we know that steel mill controls the usage of water. So the variable X is variable only for steel mill, and water for fishery production is constant. Yes. This fishery production cannot control the usage of water. It takes it as given. So, and we also see that more water, that means more pollution, more dirty water, increases the costs for fishery production. So we can conclude that this is negative externality. The steel mill, by using water, negatively influence the fishery production. Okay, so point A, we should find competitive equilibrium, find the optimal production from each firm's point of view. Is this outcome comparatively efficient? So we should find equilibrium quantity of steel, of fish, and the usage of water. This is competitive equilibrium, decentralized solution. how they decide how much to produce. They independently to each other maximizes their profits. Yes, firms maximize their profits. So consider steel production. The profit of steel production is total revenue minus total cost. Total revenue is the price of steel multiplied by the quantity of steel minus total costs. It is 10s minus s squared over 2 minus 4 minus x squared. And this we will maximize by choosing how much steel to produce and how much water to use, non-negative. In each task, you should write down the maximization program, what you will do, what you will maximize. In each task, please do not lose your points. Then, how to solve this problem? First order condition, two partial derivatives should be equal to 0. Partial derivative out of s is 10 minus s should be equal to 0. Partial derivative from x is how much? Minus 2, 4 minus x multiplied by minus 1 equals to 0 at the same time. So our steel mill will produce 10 units of steel, and she will use, but it was seen from the cost structure, yes? Optimal quantity of water is 4. Yes, for costs to be minimized, you see? So then that's all about steel production. Fishery. Profit of fishery equals to perfectly competitive price for fish multiplied by the quantity of fish minus total costs. But water used by steel mill is constant for our fishery. So we can write down that it is X star. It is chosen by steel mill. 5 minus f squared over 2 minus xf, where x is x star. And this we should maximize by choosing only how much fish to produce, non-negative. First order condition, take the derivative out of f. It is not 5 minus of 5f. 5 minus f minus x star equals to 0. X is constant for us. From here, optimal quantity of fish is equal to 5 minus x star. We know x star from the previous step. It is equal to 1. So our fishery will produce 1 unit of fish. So this is the competitive equilibrium. We'll write down one more time, competitive equilibrium. Steel equals to 10, water equals to 4, and fish equals to 1. What can you say about efficiency of this equilibrium? Is this competitive equilibrium Pareto efficient?
Absolutely no.
No, why?
Because the fish firm, they get the minimum profit from this.
Why
and also we increase the profit of steel by decreasing the profit of firm. That's why it's not Pareto efficient.
I think we should discuss this issue in terms of our fundamental theorems. Yes? What about first fundamental theorem? Firms are price takers, okay, but what is?
We have a negative externality.
Yes, and that's why what we do not have. How many goods we have in this economy? We have 3 goods. 3 goods. Steel, water, and fish. But we have only 2 markets. Yes, so markets are incomplete here. If we speak in terms of fundamental theorem, okay? Yes, and because we have negative externality and do not internalize it, we have three goods and 2 markets. Markets are incomplete, so competitive equilibrium is not Pareto efficient. Let's write down it as a conclusion. Let's write down allocation is not Pareto efficient. Because firm S doesn't internalize the cost it imposes on F. Because S does not internalize the cost it imposes on F. And we can explain there is no market for good for X. Okay. Questions about this part?
No questions.
Next. In the next point, we should find the socially desirable production plan. What is how much it is optimal to produce from the society's point of view. This is the centralized solution. So we will find right now Pareto efficient allocation. So centralized solution. Our social planner, but it maximizes. It maximizes social welfare. Social welfare always consists of the surpluses of each economic agent that presents in the market. We have here 2 economic agents, firm S and firm F. So social welfare consists of 2 profits. Yes, so we will maximize the sum of profits. Social welfare. Assume that that social planner equally cares about both firms. Okay, let's write down it. Assume social planner equally cares about both firms. And maximizes the total profit. So social welfare is the sum of profit of firm F plus the profit of firm S. Let's sum up. Profit of firm F, 5 multiplied by F minus cost minus F squared over 2 minus XF plus 10S minus S squared over 2 minus 4 minus X squared. And this we should maximize by choosing everything. Yes, by choosing how much fish to produce, how much steel to produce, and how much water to use. Non-negative. This is our maximization program. Take 3 derivatives, 3 partial derivatives by F. 5 minus F minus X equals to 0 by X minus F minus 2, 4 minus X multiplied by minus 1 equals to 0 by S. 10 minus S equals to 0. First, this is first to the condition. So 3 partial derivatives at the same time should be equal to 0 in optimum. From here, we will get that socially desirable production of steel equals to 10. socially desirable production of F. Let's find. F equals to 5 minus x. Put this into the second. Minus 5 plus x plus 8 minus 2x equals to 0. So from here we can find that socially desirable usage of water equals to 3, and socially desirable usage production of fish equals to 5 minus 3 equals to 2. So Pareto efficient allocation is still, quantity of steel is equal to 10, usage of water 3, production of fish 2. And you see that if we compare it with competitive equilibrium, water, we should use less water than in competitive equilibrium and produce more fish. So in competitive equilibrium, you see the problem of underproduction. No, not underproduction, overusage of water. Yes, overusage of water. So let's write down. Why we have in Pareto efficient allocation more fish and less water? Let's see. Here we have, when we took the partial derivative out of x, here we have the marginal costs associated with the usage of water. This part we saw in the profit maximization program of firm S. These are marginal private costs of firm F from usage water. Marginal private costs. But here, when we speak from the social planner point of view, from the society point of view, in this partial derivative, we also have this part. We also have this part, F. And this is the external effect, yes, that steel mill, how steel mill influence badly on other firm, on fishery production. So this is marginal external cost. And you know that marginal private cost plus marginal external cost equals to marginal social costs associated with, so this sum is marginal social cost associated with the usage of water. Yes? So here our social planner takes into account this bad influence. Yes? So here we internalize this negative effect. Let's write down it. Now, the marginal cost associated with the production of good X is higher. Associated with the production of X is higher. Because it includes the negative effect the S firm imposes on the F firm. So competitive equilibrium is not Pareto efficient if we compare. And we can explain that quantity of fish produced is too low in competitive equilibrium and the water usage is too high in competitive equilibrium. Quantity of fish produced is too low and the pollution is too high. Why pollution? Because when in the steel production they use water and it becomes dirty, and this negatively affects the fishery production that is located near the same lake on the same river. Okay, so here is the problem of over usage of water and of underproduction of fish. Yes. Okay, this was the second point. Please ask. And in the third point, we will discuss how government can internalize this negative effect. What to do with the steel production if it negatively affects the other production. We should, the first that comes to mind is we should impose the tax, yes, on steel production. And in this third point, we should find this tax that will internalize the negative effect. This tax is called Pigouvian Text by the name of Pigou. It's a famous economist. Pigouvian Text. What that means? Steel mill should pay tau per unit of water used. And we should find the optimal tax such that we will be in Pareto efficient equilibrium. Okay, we imposed this tax. What is happening with the profit of steel production? Profit of steel production equals to 10s minus previous costs, s square over 2 minus 4 minus x square, and minus tau multiplied by x. So our costs increase by this tax revenue. Yes? And this we should maximize by choosing S and X, non-negative. Because our steel production controls the production of steel and the usage of water. Two derivatives by S 10 minus S equals to 0, and by X minus 2, 4 minus X multiplied by minus 1 minus tau equals to 0. And you see that this text, these are new marginal private costs, but our government makes our firm to increases the marginal costs of our firm such that her new marginal private costs includes the marginal external costs of the society. You see? So what will be the answer? It was in point 2. In point 2, we had this derivative, like when we took the derivative from social welfare, we had minus 2, 4 minus x, minus 1 minus f, and we know that this is equals to 2. So from here, we will find that tau equals to 2. So in optimum, tau, optimal tau equals to marginal external costs in the point in the Pareto efficient allocation. But we can calculate. We know that optimal the usage of water equals to 3. So put this into this first to the condition and write down the answer. 2, 4 minus 3 equals to tau. So from here, tau equals to 2. This is our answer. Is it and it's exactly this marginal external cost in the Pareto efficient point. Okay, so when if you will have the task where it is written that we consider positive externality, not here we have negative externality, but if in the task you have positive externality, we will impose tax or subsidy.
Subsidy.
Subsidy. Yeah, we will have Pigouvian subsidy. Yes, for socially undesirable allocation. But if in your task with positive externality it is written, please find Pigouvian tax. In the answer, you know that it is subsidy. In the answer, what you will write? You will write this subsidy with negative sign.
Okay.
Is it clear?
Yes.
Your task is to find Pigouvian text, but you have positive externality, and you find that subsidy is equals to, for example, 2. But in the answer, you will write down -2, because your task is to find Pigouvian text, and you know that text is minus subsidy. Okay?
Mm-hmm.
Please do not lose the points on this question.
Okay.
Uh-huh. So
MEC is a marginal external cost. External cost.
Marginal external costs. Marginal.
Okay.
External, внешний, externality, внешний эффект. Costs. Costs that are for all other but not you. Private is for you, marginal costs. Marginal external for all other people around you, all other firms. And if we sum up this marginal private and external, we will have marginal social costs of all people. Okay, so that's all about this task. Let's continue. Our next problem is about public goods. One more market failure that we should consider today. What is the public good? It is non-competitive and non-excludable. What that means? Public good, if you do not pay for it, if you, for example, if you do not pay taxes, you cannot be excluded from consumption of this good. That's why government cares about this public goods provision in our world. The example of the public good is traffic light, or the light on the street, or the bench on the street. That's all public goods, because you cannot exclude from production the guy who used the light of traffic light if he did not pay taxes. You can also you can't exclude people who did not pay taxes from consumption of national defense. National defense is also the public good. Okay, so, and here is the problem. If I do not pay, I can use this good. And that's why we have incentives not to pay. Yes. That's why if we decide by ourselves without government intervention, there will be the problem of underproduction of public goods. That's why government produces these goods. Okay, let us consider problem 2, public good provision. What we have in this task. Consider 2 families, A and B, who must decide how much to invest in a common non-excludable playground. So this playground is non-excludable, that's why it is public good. Common playground. Let XA and XB note spendings for family A and family B, how much they will invest. And X equals to the sum is the total amount invested in the playground. And more it is invested in total, better is the playground. Family A has one kid and its payoff looks as follows. So we have family A and family B. The payoff of family A equals to ln xa plus xb minus her spendings on investment. Payoff of family B, who has 2 kids, is 2 multiplied by ln xa plus xb minus xb. So we see that their payoffs, it's like utilities, profits, payoffs, yes? They depends not only your investment, but on the whole investment, total investment to the public good. More is invested in total, better for your family. Okay? So then the families make their investment decisions about XA and XB simultaneously. So they simultaneously decide how much to invest. Simultaneously decide how much to invest. For simplicity, assume neither family A nor family B face any budget constraint. So in hard tasks about public goods, we also have budget constraints because, for example, you cannot invest more than your income, yes, more than you earn. But in your course, you will not have budget constraints. So they can invest as much as they want. First, derive the best response function for family A, then derive the best response function for family B and find Nash equilibrium. It's the problem as a Cournot model. Let's see. So they simultaneously and independently to each other decide how much to invest. So the consider family A. Family A maximizes her payoff. And she maximizes it by choosing how much to invest. Her investment non-negative. Taken the investment of the family B as given, so it is constant for her right now. Take the derivative. It is equal to 1 over xa plus xb minus 1 equals to 0. From here, we will find the best response function, how much to invest, depending on how much family B invested. So it will be the best response function of family A, her best strategy out of family B decision. And this is how much? Let's find. It is 1 minus xb, only if, what condition we should write?
If the b is less than 1?
Yes,
Less
exactly.
than or equal?
Yes, if xb less or equal to 1. Yes, if the other family is invested not too much. And we will not invest if family B invested more than 1. You see, because xa should be greater or equal to 0. And check. 1 minus xb should be greater or equal to 0. So when it is so, xb less or equal to 1. Yes? So please, please always write 2 parts of this best response function. Do not lose points. If you will write only this part, you will get only 1/4 of points. So let's draw. Like in Cournot, we will have investment decisions xa and xb, and let's draw a best response function for family B. Her optimal reaction on the decision of family B. So 2 parts. This is a linear function with negative slope. If xb is equal to 0, xa is equal to 1. If xa is equal to 0, xb is equal to 1. And the second part, xa is equal to 0 if xb greater than 1. It's where? Xa equal to 0 if xb greater than 1. It's vertical line here. So, and please write down the name of this line. It's best response for A. Put points 1, 1, and write down, name the line, please, because if you do not name the line, or if you do not name axis, so you will not get points for this, because when we grade, we do not understand what you draw if you do not name it. Then next, for family B, we maximize her payoff to ln xa plus xb minus xb. We should maximize by choosing how much to invest by family B. For family B, the decision of family A is constant because they simultaneously decide. So first order condition, take the derivative by xb equals to 2 over xa plus xb minus 1 equals to 0. From here, best response function for family B is the optimal decision dependent on the decision of family A as a function, and it is equal to, from here, you see 2 minus xa, only if investment of family A less or equal to 2, and we will not invest if family A invested more than 2. And let's draw it also on the graph. 2 parts. If xa is equal to 0, xb is equal to 2. Here. If xb is equal to 2, xa is equal to 2. Then, if xa bigger than 2, xb equal to 0. Horizontal part. Name it best response of family B. And also on the graph, we will see, we can see the intersection of the 1 point of intersection of best response functions, and it's here. And this is Nash equilibrium point. Xa star equals to 0 and 2xb star. If your task is to find Nash equilibrium, to find this in first point equilibrium when they decide simultaneously and independently to each other, and then it is written depict this equilibrium on the graph. You circle it, write down it, Nash equilibrium or equilibrium, and put the points xa star equals to 0, xb star equals to 2. So this is a good graph, good illustration for not losing points. Okay, analytically, it's a third point. We should find equilibrium. Nash equilibrium, by definition, is the situation when the set of optimal strategies such that no one wants to deviate from their decisions. Yes, so it's the investment decision of A and investment decision of B such that investment decision of A is the best response of family A by the decision of family B, and at the same time, investment decision of family B is the best response of family B on the action of family A, and it's at the same time. we can write down on the from the graph, we see where these best response functions intersect. Yes, from the graph. XA star equals to 0, XB star equals to 2. So the provision of public good equals to the sum of investments 0 plus 2 equals to 2. And what you can see? You can see that family A does not invest, but use this common playground. So here is the problem of free riding from family A point of view. Free riding проблема безбилетника. Let's write down it. A is free riding on B. And explain. It enjoys the common playground, but doesn't make any contribution to the public good. It enjoys the common playground, but doesn't make any contribution to the public good. So here we have the problem of under provision of public good. If we speak about the equilibrium with when families simultaneously decide how much to invest by themselves. По-русски это равновесие с добровольным финансированием. And you can see that only family B with 2 children, she cares more, family B cares more about this playground. So only family B invest. And family A cares less about the playground because they have only 1 child. So they do not invest. And this is the problem of such concept of equilibrium. That only those who cares the most, they will invest, and all other who cares less, they will not invest. If we will have 5 families with 1, 2, 3, 4, 5 children, the equilibrium will be that only a family with 5 children will invest. That's the problem. And other families with 1, 2, 3, and 4 children, they will not invest, and they will be free riders. Okay. What you can tell me about socially desirable provision of public good? What will be Pareto efficient? How much to invest in total is Pareto efficient? Yes. What you can tell me? How much it is efficient to invest in total? The amount of public good, Pareto efficient. Any?
This is not Pareto efficient because only one.
Yes, it's not Pareto efficient, but what will be the amount, the Pareto efficient amount of public good provision? Not 2, but how much?
Maybe 3.
3, yes, because you see how we found it. Here was 2, and this was the answer for us for family B. And here is 1, you see? So 1 plus 2 equals to 3. We will find it right now, but I thought that you will not guess, but you will understand what is the socially desirable provision of public good. Our next point is the socially desirable provision. 0.4, Pareto efficient. Pareto efficient allocation, how we find? We discuss centralized solution. One more time. Social welfare consists of the surpluses of all economic agents that are presented in the economy. Now we have two economic agents, family A and family B. So social welfare will be the sum of their payoffs. So it will be payoff of A plus payoff of B. Ln XA plus XB minus XA plus 2 ln XA plus XB minus XB. And this we will maximize by choosing XA and XB non-negative. But you can see that social welfare is 3 ln XA plus XB minus XA plus XB in brackets. And you see that if you will take two derivatives, partial derivative by XA and XB, they will be the same. So this linear system will be dependent, yes? We will not find the exact amounts of investment for each family. We can only find the optimal Pareto efficient sum of their investments from here. So we can rewrite the 3 ln x minus x, and this we will maximize by choosing x non-negative. Let's take the derivative by x. This is 3 over x minus 1 equals to 0. And you see that socially optimal is to to invest 3 in the common playground, as we expected. You see? And we cannot find the exact investments of family A and family B. It's the other question. It is not asked in this task. So this is Pareto efficient Pareto efficient provision of public good, and this is more than in Nash equilibrium. So we see the problem of underinvestment. Let's write down. Okay, let's write down it. In the market interaction, in this Nash equilibrium, in the market interaction, the families do not account for all of the positive side effects of their investment. Yes. So family A, she cares only about herself, but do not care about family B, because when family A invest something, she increases the payoff, not only her payoff, but the payoff of other family, but she doesn't care. That's why here is the problem of under provision. Let's write down. In the market interaction, the families for example, A, do not account for all of the positive side, do not account for all the positive side effects of their investment, and hence underinvest. Please ask about this task.
Everything is clear.
Okay, let's consider some problem from your, let's see. from exam 29. Let's see. Okay. Please open your net Anastasia sent you from 2019. Where it is. Final test. And let's solve this problem about externalities one more time. Or,
Is it problem 4?
What?
Is it problem 4?
Let's see. Problem 2 about production externalities. Problem 4 is public good. Yes, you want public good. Okay, let's do public good. Problem 4. Actually, I don't remember this task, so we'll solve it together right now. Public number 4, 2019. Two families, A and B, live in a village where all the houses are made of wool. To protect their houses from fires, the families must invest in a fire station. The utility each family extracts from private and public consumption looks as follows. So the utility of each family from the consumption of private good and public good fire station equals to 2 ln CI plus ln F for each family A and B. So you see that F is public good and C is private good. Consumption. CI corresponds to families I's expenditures on private consumption, and a fire station equals to FA plus FB, how much both families together invested in her construction. Total public good investment. A and B face identical budget constraints and can spend on C and FI more than 100 monetary units. So budget constraint will be CI plus FI, no more, this is budget constraint for family I, no more than 100. So point A, find the optimal private consumption and the total investment in the fire production if families make their decisions independently and simultaneously. It's Nash Equilibrium. Decide simultaneously and independently to each other. So consider family, for example, family A. What will be her maximization program? She will maximize her utility subject to budget constraint. Clear? So maximize her utility to ln CA plus ln FA plus FB. This we will maximize by choosing how much to consume and how much to invest in A, non-negative, subject to CA plus FA less or equal to 100. So this is the utility maximization program for our family A. Our first step is to prove that budget constraint holds as equality. How we will prove it? We can say that our preference is monotonic or locally non-satiated. So here will be equality as preferences locally non-stated or monotonic. Strictly monotonic or non-strictly, no mind. It's first step. Then, second step, we can solve this problem in two ways. We can, from budget constraint, we can find CA, put this into utility and maximize, or we can use this first order condition for interior solution. Marginal rate of substitution equals to prices of two goods. Let's use the first option. So from budget constraint, CA equals to 100 minus FA. Put this into utility. To ln 100 minus FA plus ln FA plus FB. We should maximize by choosing here FA, and this here will be belongs from 0 to how much? To 100. Yes, no more than 100. Okay. Take the derivative by FA. This will be 2 over 100 minus FA multiplied by minus 1 plus 1 over FA plus FB equals to 0. From here, solve this, and from here we will find the best response function. Okay, how much? 2 over 100 minus FA equals to 1 over FA plus FB. Make this cross. 2FA plus 2FB equals to 100 minus FA. So 3 FA out of FB as a function will be equal to how much? 100 minus 2FB over 3. Yes, only if, what condition? Only if is the best response for A. Condition.
FB is less than 50.
Yes, this should be greater or equal than 0. So this is true only if 100 minus 2FB greater or equal than 0. That means that investment of family B should be less or equal than 50. And we will invest exactly 0 if investment of family B higher than 50. Is it clear? Best response. We can say that same for family B. Same steps for family B. We will maximize. Okay, best response for family B. No, let's write down the utility maximization program of family B. Subject 2 for budget constraint. And we can write down best response. minus 2 F A over 3 if investment of family A less or equal than 50, and 0 if investment of A higher than 50. Then let's draw a graph with investment in forestation. Here FA, here FB. Best response for A. It's linear function with negative slope, so by 2 dots. If FB is equal to 0, FA is equal to 100 over 3. FB equal to 0, FA 100 over 3. If FA is equal to 0, FB is equal to 50. and FA is equal to 0 if FB higher than 50. This part. This is best response for family A. Symmetric is for B. Best response. Here 100/3, here 50. This is best response for B. And we see the intersection is Nash equilibrium. This FA star, this FB star, and we will find them. One more time, we write that Nash equilibrium is optimal strategies of two players, such that strategy of family A is the best response of family A on the action of family B, and strategy of family B is the best response of family B on the action of family A at the same time. And we see on the graph where our best responses intersect. So from the graph, we should use this linear functions parts, yes, with negative slope. So FA equals to 100 minus 2FB over 3, and FB equals to 100 minus 2FA over 3. How to solve it? We can make one plus, and that's all. So we should solve this linear system. We can sum up and say that F total investment is equal to 200 minus 2F over 3. Yes, so 3F equals to 200 minus 2F. 5F equals to 200. So F equals to how much? 40. So what else? And also we know that as they are symmetric, they will invest the same amount. Yes. So 20. Yes. As they are symmetric. 1/2 they will invest. Okay, so they will invest 20 each, and but that is not all, because also we should find the private consumption. Private consumption of family A equals to private consumption of family B equals to 100 total income minus investment in fire station 20. So it will be 80. And this we'll also write down in the answer. Let's see. Using utilitarian social welfare function, find the pretty efficient total investment in the fire protection. Is it greater, smaller, or equal? So that's all about this Nash equilibrium. Please, questions about this? I will Google. I think utilitarian is the sum of their utilities, and that's all. Utilitarians considers the interests of all humans equally. So we should sum up we should sum up these utilities without when a social planner cares about both families equally. So point 2, Pareto efficient allocation. So a social planner will maximize the sum of the utilities to ln CA plus ln F plus 2 ln CB plus ln F. This will maximize by choosing CA, CB, and F non-negative, subject to the total budget constraint. CA plus CB minus plus F less equal than 200. Yes? These are the expenses of our society. These are the incomes of our society, total income of our society, 200. So first we prove that budget constraint holds with equality. Preferences are locally non-satiated or monotonic. Then what also we can say. Okay, we can from here we can extract F, yes, and solve with CA and CB. So F from budget constraint will be 200 minus CA minus CB. Put this into utility, 2 ln CA plus 2 ln CB plus 2 ln 200 minus CA minus CB. And this will maximize by choosing the private consumption of family A and private consumption of family B non-negative. So take two derivatives. Social welfare prime out of CA, 2 over CA. From here, plus 2 over 200 minus CA minus CB multiplied by minus 1 equals to 0. And symmetrically, social welfare out of CB equals to 2 over CB minus 2, 200 minus CA minus CB equals to 0. Solve this problem. You see that 200 minus CA minus CB should be equal to CA. Yes? So also we get 200 minus CB equals to CA, and this over 2. Okay, no mind. So from solving this problem, CA star should, okay, let's say CA with head should be equal to CB with head, because they are symmetric, symmetric families equals to how much? 200 over 3. Yes? And public good provision fire station should be equal to how much? 200 minus CA minus CB, minus 200 over 3 minus 200 over 3. This is 200 over 3. And now we can compare the Pareto efficient allocation. This Pareto efficient allocation we can compare with Nash Equilibrium investment, total investment in public good. we see that social desirable 200/3, it's how much approximately? It's 60.
So
67, yes, approximately 67. It is more than in our Nash equilibrium. Nash equilibrium, it was 40. So we see the problem of underinvestment. Why? Because when our family decides simultaneously and independently, they think only about themselves and do not take into account that their actions will positively affect on not only on them but also on other families. And if your task is explain, you write down all this explanation, as in previous task that we solved. What else? What else? Explain the intuition. Yes, under investment. But please, I do not want to write down one more time this. In the market interaction, the families do not account for all of their of the positive side effects of their investment and hence underinvest. This explanation, okay, from the previous task. What else? The mayor of the village wants to restore efficiency and decides to increase the investment in the fire protection by 35 monetary units. To do so, he imposes the tax of 20 monetary units on family A and 15 monetary units on family B. As before, both families still can make a voluntary contribution to the public good. Find the new total investment in the fire protection. What is the contribution of family A? Tax of 20. I don't remember. I will not solve it fast right now. 20 units on A. So the income of A will be not 100 but 80. 15 monetary units on family B. Okay, I got it. Can I erase this?
yes.
Third. You see. So now this amount of public good will be FA plus FB plus 35. That is the investment of mayor. Yes, understand? Plus 35. Then, to do so, he imposes the tax of 20 monetary units on family A and 15 monetary units on family B. So now budget constraint of family A will be CA plus CF plus FA less or equal to 100 minus this tax on A, minus 20. So this is 80. And budget constraint of B will be CB plus FB, expenditures of B, less or equal to 100 minus how much? Minus 15. This is 85. As before, both families still can make voluntary contribution. Find the new total investment in fire protection. How does this compare to the level of public good provision found in point 1? Okay, these are our new conditions. So utility of family A will be 2 ln CA plus ln out of F, out of FA plus FB plus 35. And this it should maximize by choosing CA and FA non-negative. Subject to new budget constraint CA plus FA less or equal than 80. first proof. Then write down that CA8 minus FA FA now belongs from 0 to 80. Yes, that matters. Then take the derivative, minus 2, 80 minus FA plus 1 over FA plus FB plus 35 equals to 0. Can I write fast, because we don't have time. This is fork for A, fork for B. You should write down as in the first point, approximate maximization utility maximization program of A, then best response, then cross them, and blah blah blah. But I want to solve, so this will be fork for B also. Minus 2 here will be 85 minus FB plus 1 over FA plus FB plus 35. And this should be equal to 0. This we should solve, because the intersection of best responses will be on the linear part with negative slopes. So this part, when it is equal to 0, when first derivative equal to 0. And what we will find? A minus FA equals to 2F plus 70. And from here, 85 minus FB equals to 2F minus 70. We can say that this plus 70 plus 70, these parts are equal, so 80 minus FA equals to 85 minus FB. So FB will be equal to 5 plus FA. Why? Because you see that family B will invest more than A. Why? Because B has more money, 85, and A has 8. Put this somewhere. 8 minus FA, or we can find, we can sum up them also. 80 plus 85, 165 minus F equals to 4F plus 140. Yes, 5F equals to 125. F will be equal to 125 over 5. How much? 25, yes. No, not 25. That's not true. That's not true. Where is mistake? Yeah, okay, I got it. That's not right. We cannot sum up because our F.
It should be.
Yes, and this F also, it's not F, it's FA plus FB. Yes, here. And here, FA plus FB, because our F is FA plus FB plus 35. Okay. Yeah, that's true. That's true. Then put, for example, okay, 8 minus FA equals to 2 FA plus 5 plus FA plus 70, and from here we'll find right now 4 FA plus 10 plus 70. Yes? Am I right? 10, 2.
I don't know.
calculations. I think yes, 3 of FA equals to 0. So FA will be equal to 0. Right now, FB will be equal to 5. And public good here will be equal to 0 plus 5 plus 35, 40. Yes?
Yes,
And
yes.
it was as in the first point. Equals to F star from point A. Why is it so? Because it's the equilibrium with, let's say, when they invest simultaneously and independently to each other, and they understand that this 35 is investment by the government from their incomes. So you see that it's like the tax. We can put this tax here, and you will see that it's the same. The sum of tax 20 plus FA is exactly the investment of A, how much it wants to invest into the public good provision. And for B also, FB plus 15 is also 20. It's how much it wants in equilibrium to invest. Yes?
Okay.
Yeah. So FA star plus this tax plus 20 equals to 20. And this is exactly F star A from point A. FB star plus 15 plus tax is 20. And this is exactly how much it wants to invest in point A. So their decision on how much to invest, it did not change. The part is the tax and it is paid. Okay. That's all about this task. Okay. So,